10 days, and my phone will tell me what the weather is going to do for the next 10 days. And right now, it says that back of all of this week that we have come till now, it has been monsoon has been on and off in India, the 50% chance of rain, there is a high visibility, and there is probably a chance of 10 to 15% precipitation over the next 3 to 5 days. And I believe it. And I will probably plan around it. And if it says it's going to rain on Sunday, I'm not going to make any plans that needs a dry afternoon. And I have done this every week of my adult life. And I have never once stopped to ask why and how it knows. Take any location for that matter: Bengaluru, Delhi, Ahmedabad, Kolkata, Bhopal. The same app, the same 10 days, every one of them with an answer which is ready even before I asked. And this is not something new or which stops at a border. 10 days, every one of them with the same answer ready even before you asked. Take it outside the borders as well. London, Nairobi, Shanghai, Sao Paulo, New York, different corners of the world across the continents, and it does not stop at the border. Almost every pocket on this planet is carrying that same screen. Most of the people holding one of those screens definitely checked it in this morning and before they decided what to wear, where to go, and how to plan for the rest of the week. And go on, you know what? Take a second and check yours. And I'm talking about the weather app. Now, here is the part that stopped me when it finally landed. None of it has happened yet. Not one number on that screen is a measurement. One number on that screen is not a measurement that determines what the week is going to look like. Sunday has not occurred. Nobody has been to a Sunday and come back to tell you what or with what that temperature looks like. Every figure that you are looking at is probably a guess produced by a machine that looked at the sky, looked at its own records, and made a decision about what your week is going to do. And that screen is probably the most widely used piece of climate technology on Earth. And literally, including myself, thinks of it that way. I certainly did not, at least for 30 last years. The last 9 years I spent in pharma, I worked on not a climate subject, and I am not a scientist. I am learning this properly now from the source documents rather than from the headlines on the news articles, and I am putting what I find here in plain language as I go. Everything I say is linked below, and if I get something wrong, the sources are sitting right there for you to help me understand. So come back and tell me if I did so. So, let's start with the thing that almost everybody mixes up on the planet, because the rest of it, or the rest of this whole video, falls on it without even telling you about it: weather and climate. Now, these are not the same words at different volumes. Weather is what is in your wallet today. That is the easiest way you can think of it. Climate is what is the income going to be in next 10 years. You can open your wallet on a Tuesday, find nothing in it, and still be doing perfectly well. You can have a rough month and still be earning more than what you were 5 years ago. And you can have a genuine cold week sitting inside a decade that is warmer than any decade before it. Now, both of those are actually true at the same time. People reach for ways to argue on either of those constantly. A cold snap in Delhi becomes a joke about global warming. One hot afternoon becomes proof of an apocalypse. And neither proves anything because the day is not a decade. And there is much shorter way of putting this across. I picked this up in a lecture earlier this year, which was out of interest that I attended, but was from someone that I have known in climate for a long time, a scientist called Benjamin Cook. Climate is what you expect and weather is what you get. That's all. He just said it in 9 words. That is the whole distinction, and everything else I am about to say sits on top of it. Imagine this: the 9 words which he said literally shapes the entire understanding of everything else that I am about to say, sitting on top of the subject which is presumed to be hard. The one you can expect, where the animations from NASA puts out every January, a map of the world, 140 years of surface temperature. Blue is where a year came in cooler than the middle of the last century, and red is where it came in warmer. Now, for the first long stretch, it flickers. Blue here, red there, no pattern you could point at the same time. But that is the weather doing exactly what weather does. Then somewhere past in the middle, the blue stops coming back. The red starts to get deeper and they spread, and they do not retreat. By the end, there is almost nothing cool left anywhere on that map. Not a single day in that whole animation decided anything. Let me repeat. Not a single day on that decided anything. Not one storm, not one hot afternoon in one city. The shape only appeared once you stop looking at the days and start looking at the decades. That is the difference between weather and climate, watched rather than explained. And here's the first thing that genuinely surprised me when I started reading that properly. Your app can only guess what tomorrow could be because it has been fed the millions of yesterdays. Temperature, pressure, humidity, wind, rainfall, and many other parameters gathered at weather stations and ocean buoys and from satellites and every other piece of technology that you can remember or come across every single day for well over a century. Now, that archive is what a forecast is built from. It is also exactly the most unavoidably the climate record every single app throws across at every instance of time. The same measurement, the same is what a forecast is built from. It is also exactly and unavoidably the climate record. The same measurements, same stations, same numbers again and again. Weather forecasting and climate science are drinking from the same well, whether you like it or not. The thing in your pocket is not sitting next to a climate science, it is actually running on climate science. You have been using climate data every morning of your life and calling it checking the weather app. Now let me do something that looks similar, but it is not. Just go on your Google and type "why is it so hot" into the search box. And I get a confident, well-written, fairly accurate paragraph in about roughly 5 to 10 seconds, or probably even a second. And honestly, it feels like the same kind of intelligence that told me about Sunday. It is not. Let me be honest with you on that. It is really not. It is a completely different animal wearing the same name. That machine did not measure anything. It has never touched a thermometer. It literally read from what other people wrote about heat, or at an enormous scale what it learned, which it follows to the other words by linking across the documents. When it answers me, it is producing from a very good sentence about heat. It is not producing a finding about heat. The other machine, the one sitting behind your forecast, has been fed measurements, physical readings taken off physical instruments, standing in physical places. One of them has read every book written about ocean. One of them has every answer about the ocean. The other has been swimming in it for last 40 years. Ask them both what water feels like today and you will get two confident answers. Only one of them has actually been in weather or the water. Both are called artificial intelligence. They both are called the AI, and both get talked about in the same breath at conferences, in the pitch decks, in the government announcements, and everywhere. So when somebody tells you AI is going to solve climate change or that AI is wrecking the planet, the first useful question is which of these two they actually mean. The answer changes completely depending on that. Your weather app is the second kind, the one that has been swimming in that water for decades. And you already understand how the second kind works because you have been doing it literally yourself for years now. You have driven the same road 500 times. You know on a Monday morning it is going to be bad. You know that one stretch near a flyover floods when it rains. And you also know that it floods before anybody announces it on news articles because you have watched it happen. You know which lane moves and you know which one looks like it is moving. Nobody calculated any of that for you. You never worked it out on a physics or a chemistry of the water on the tarmac. You never modeled the traffic yourself. You built a feel for it by probably traveling 500 repetitions, and now you leave 20 minutes earlier on a Monday morning without even consciously deciding to. And that is the whole trick. The machine has driven a road great many more times than you have, and it has seen this exact arrangement of pressure and moisture and wind probably building again and again for thousands of times before, and it knows usually what comes next. And not because someone sat down and taught it the rules of the atmosphere, the ecosystem, the ecology, but probably because it watched over and over until the pattern was very obvious, which means the whole thing turns on one question: how closely is it allowed to look? And this is where I found the piece that actually changed how I have been thinking about this on the field. The machine that models the climate cuts the world into boxes, small grid squares laid over a surface on the planet, and then the whole model works out like what is happening inside each of those tiny boxes. For a long time, those boxes were around 100 kilometers side. 100 kilometers, your entire sits inside one tiny box. And every hill, every lake, every industrial estate, every school, every college, every institution, every neighborhood flattened into that one number. A model can tell you a great deal about the planet and almost has nothing useful about your street. And then the boxes get smaller. First into lengths of a kilometer, and now it is into places down to a few kilometers by side. At a few kilometers, a lake starts to look like a matter. A ridged line starts to look like a matter. One side of the city can be sold or told something completely different from the other side because at that size they are genuinely different places. There is a word making those boxes smaller, and it is in simple terms called downscaling. That is it. That is the whole word. And the concept, and you now know something that most people working in this field use every day without ever stopping you to explain it. Do you know that divider which used to come along with your compass in your school that you often used to measure when you're drawing a map on your geography lessons? It is literally that downscaling in a concept of climate space or climate intelligence or the entire map knowledge that it comes down to that you use every day without ever stopping to explain it. The next time somebody says it in a presentation, you will know exactly what they are claiming and what exactly that body of UN or UNICEF actually mean. So, the machines got better. The archive got longer. The boxes got smaller. And that forecast got sharper. Well, I didn't know I can rhyme, but there you go. Which should mean that fewer people get caught in the whole mess. In 2023, the heaviest rainfall that was ever recorded anywhere in Brazil landed on a street of São Paulo state. The forecast was actually right. The National Monitoring Center saw it coming, and the Brazil has a proper structure for this. A center issues the alert, it goes to the state and the municipal civil defense, and then they work with the fire brigade, and the fire brigades are the ones who are meant to reach the people and get them to the slopes where it is safe. The warnings went out. People on those hillsides died anyway. I'm sorry to say, but they actually did go through what they were not supposed to go through. Not because the science failed, the science actually worked. It came apart somewhere in the last few hundred meters between an alert on the screen in a monitoring center and a family asleep in a house on a slope at 2 a.m. in the morning. And we have seen this happen across every part of the world. And the researchers who went back and studied it afterwards did not ask for a better model. They asked for a local community to be bought into the whole planning and for an evacuation plan that actually gets built around the people who are in those critical areas. Human problems, and every one of them, it's practically the same issue that you see. Nairobi does not have a flood warning system that arrives early enough for them to act on. Not because the city is careless, but because the pieces underneath are still missing. The same with India. The historical record of whether the water has gone before, or where the water has gone before, or the map of which areas are exposed, the information that you need before you can even warn anybody about anything, probably are still missing. A study opened this in July to work out what such systems could even require. Two cities, two failures, opposite ends of the same gap. But in one of those, a message arrived and it did not travel the last mile. In the other one, it actually did, but it never left the building. In pharma for 9 years, I have seen and worked in an environment, and the thing that we planned around was never the storm. It was probably the 4 days afterwards, when the road reopens and somebody has to work out whether the cold chain held while the power was down, whether the supply held when the power was down, whether the stock in that fridge was still worth anything after a flood, and whether a person who was due to collect the month of medicine ever came back to collect it. And usually nobody finds out about the last one, and they simply do not come back, and that number keeps moving, and by the time anyone notices, it looks like a poor adherence rather than a flooded road. And the forecast was never the hard part. It is probably, which I believe, which is the part that I keep coming back to. The warning was never really about the sky. It was about the weather that the family moved their things upstairs to avoid from the flood. Whether the clinic shifted its medicine before the power went down. Whether the health worker could actually reach the village on a Thursday morning before the floods happened. The machine got very good at the sky, let's agree. Measurably better decade after decade, and that is the real achievement by a lot of serious people achieving this day on day. But the gap also moved. It sits now in a distance between a screen monitoring the room and a person standing on a hillside at 2 a.m. in the morning. I'll say again, it sits between a person monitoring a room and a person standing on a hillside at 2 in the morning. And that distance is a human problem, not a physics one, not a weather one, not a climate app one. Nobody needs a breakthrough to close it, which is exactly why I find it worth working on and spend my time. And exactly why it is taking so long. Everything in this video came from a handful of places, and all of them are linked below. Believe me, a joint report from a global partnership on AI and the OECD, the two papers from Technology Committee which were at the UN climate change, also the surface temperature record from the NASA Institute, which basically showed the animation of 140 decades of climate change. The lecture where I picked up the 9-word definition, literally again from a source which already exists, and published research from 2023 rainfall data, which actually told about people who died at 2 a.m. in the morning, and on the flood forecasting gaps in the Nairobi, or the reference I made to India. If I've got something wrong, go back and check, and then come back to me and tell me about that. We probably will learn it together. But the two things before you go, tell me, if I circle back onto this whole thing, tell me what your app said today and whether, or rather, let me rephrase, tell me what your weather app said today and where in the world you are watching this from. Because I want to see how far this reaches. And one last thought, all of this runs on machines that lives somewhere. Physical buildings, probably drawing real power from a source which never existed 5 years ago, sitting on a real ground in real places with real neighborhoods, and affecting the ecosystem in ways we probably did not imagine. Where does this all data actually live, and what does it cost to keep running on it? That is the next one that I'm making. And if that is a question that you walked in with, go and find it, and let's catch you on the next one.